Okay, so we're continuing with where we left off. Mu naught, 6.8. X bar is supposed to be 6.7. SX is 0.35. N is 39. And we're going to select mu is not equal to mu naught. And then hit calculate. Right, then select calculate. Hit enter. And here's what shows up. Let me show you what shows up. T-test is at the top still. And then we have below it, it'll remind you mu not equal to 6.8. So it reminds you what is your alternative hypothesis. T equals negative 1.7842854142. P equals 0.0823638,462. X bar equals 6.7. SX equals 0.35. N equals 39. Okay, so let me explain or remind you of the printouts. What is this stuff? Okay, this top line here, this is your HA. Okay, so this should align with what you chose back in step 2. Okay, so it should align with what you chose back in step 2. This next line here, this is your standardized test statistic. So remember the formula for this is, T equals X bar minus mu over S over square root of N. Okay, so the calculator calculates and spits out the standardized test statistic. P, this is your p-value. So this is the probability of getting a sample as extreme or more extreme than what we got if the mean actually is equal to 6.8. X bar, we know what that is. SX, this is our sample standard deviation. X bar is just X bar. And then N, we know what that is. All right, we're ready to make a decision. Now remember, how do we make a decision? It's based on P and alpha. So our P is 0.08236, right? So our P is 0.08236, and our alpha is 0.05. Okay, so remember the question that we need to ask, right? How are we making our decision if we are using the p-value method? Is the p-value less than or equal to alpha? So we've got our p-value from the calculator, and we've got our alpha from the problem. And we say, is the p-value less than or equal to alpha? If it is, reject H naught, and if it's not, fail to reject. Okay. So our p-value is 0.08236, and our alpha is 0.05000. P-value is not less than or equal to alpha. So since p-value is not less than or equal to alpha, we fail to reject H naught. Okay, now we're ready to interpret our decision because our claim is H naught and we fail to reject H naught. So if our claim is H naught and we fail to reject H naught, claim is H naught and we fail to reject H naught, so there's not enough evidence to reject the claim. Okay. So at the 5% level, there is not enough evidence to reject the claim. And what was the claim? The claim is that the mean pH level is 6.8. That the mean pH level of the water is 6.8. Okay, so maybe if we had gotten a sample with a more extreme pH value, sample mean, if we had a sample with a more extreme sample mean, then, we would have been able to reject the claim or something like that. But there just is not enough evidence based on the sample that we took that the claim needs to be rejected. All right, so let's do this last example here. And with this example, I'm going to show you how to fill out the chart, okay? So it says a motor vehicle office, a DMV, Department of Motor Vehicles office. So this is the DMV. So a DMV office claims that the mean wait time is less than 14 minutes. A random sample of 10 people has a mean, a mean wait time of 13 minutes and a standard deviation of 3.5 minutes. At alpha equals 10%, test the office's claim. Assume the population is normally distributed. Okay, so let's go to our form here, and we are supposed to, actually we should have put this out probably on the exam. I might move this number 4 and make it number 1, because you need to know the requirements for the test before you start performing the test, right? So here, what are the requirements for the test? Well, for the test, we need to, for using the t-test, we need to know that, we need to verify that sigma is unknown. We also need to verify that the sample is random. And we need to verify that the population is normally distributed, or n is greater than or equal to 30. Okay. So now verify that sigma is unknown. And how do we know that sigma is unknown? Well, we are given a DMV office claims that the mean wait time is less than 14 minutes. A random sample of 10 people, so n is equal to 10, has a mean wait time of 13 minutes. So x bar equals 13 with a standard deviation of 3.5 minutes. So S is equal to 3.5. At alpha equals 10%. So we're not given any information about sigma. We're only given information about S. So let's write this here. So sigma is unknown. No info for sigma is given in the problem. Verify that the sample is random. Assume the population, a random sample. So we can just say here, stated in the problem. Okay, verify the n is greater than or equal to 30 or the population is normally distributed. So for our problem here, it says assume that the population is normally distributed. So we'll circle population is normally distributed, and then we'll just say stated in the problem. Okay, so we've done that. Now let us state the claim mathematically and verbally, identify the null and alternative hypotheses. Okay, so let's see here. So it looks here like our null hypothesis is, well, we can't do the null hypothesis just like that. We need to write the claim. So what is our claim? Our claim is office claims that the mean wait time is less than 14 minutes. All right, so our claim is that mean wait time, I can write it right here. The mean wait time is less than 14. This is, by the way, laughable. Less than 14 minutes at the DMV. Give me a break. Even when I get an appointment, it's never less than 14 minutes. I mean, I'm not hating on the people that work at the DMV or anything like that, but I'm just saying that's just been my experience. Okay. Because I had somebody who was like, my sister works at the DMV, and they work very hard. And I believe they work very hard. Okay. Mean wait time is less than 14 minutes. State the claim mathematically. Now, mu is less than 14. Okay? Now, to the side here, I know that in order to get my null and alternative hypotheses, I need to take the complement. So my complement is going to be mu is greater than or equal to, 14 is a complement.
Yes, I know.
And now, which one is the null hypothesis? The null hypothesis is going to be this one because it involves greater than or equal to. So let me put in here mu greater than or equal to 14. And then for my alternative hypothesis, it's going to be mu less than 14. The claim is the alternative hypothesis. So I'm going to check that one off. Specify the level of significance. Alpha is 10%. So let's see here. So alpha is equal to 10%, 0.1. Determine the appropriate test to perform. Okay, we are going to be doing a t-test because sigma is unknown, right? State the distribution used in the test. It is a t-distribution. Why do we know that? How do we know that? Number one, if you forget, the easiest way is to say, hey, it's written in the problem, right? It's a t-test. For a z-test, you're using the z-distribution. For a one-prop z-test, you're using the z-distribution, right? For a t-test, you're using the t-distribution. Okay, please turn over. Find the standardized test statistic and the p-value for this test. Here's how I'm going to do that. I'm going to put in my calculator. So I'm going to go to t-test, and so I'm going to go to stat, test, go to t-test. Now I'm going to select stats. My mu naught is going to be 14. Do you see that? So my mu naught is going to be 14. So this is for the t-test. Mu naught is 14. My x bar, I'm going to put 13. Put 13. My sx, that's the same as s, so I'm going to put 35. For my n, I'm going to put 10. And then for mu is it not equal to mu naught? Is it less than mu naught? Is it greater than mu naught? I need to look at my alternative hypotheses. So I look here, and apparently I need to use oh, my alternative hypothesis is right here, right? So I need to use less than. Okay, see how that's a less than? So over here, I'm going to select less than. And then I'm going to hit calculate. And my output, mu less than 14, t equals negative 0.09035. Okay, p equals 0.46499. X bar equals 13. Sx equals 35. N equals 10. Okay, now I'm ready. What is the standardized test statistic? It is t equals negative 0.09035. What is the p-value? P equals 0.46499. Explain in one or two sentences, in one or two complete sentences, explain what the p-value means for this problem. So the probability of obtaining a sample as extreme or more extreme than, because what did we obtain? We obtained a sample, I believe it was a sample mean, right? So it's a sample mean of 13 minutes, right? A sample, so let me go in here and modify this. A sample mean as extreme or more extreme than 13 minutes is, what is the probability? Probability is 46.49. Wait a minute, this seems very, very high. Let's look back and make sure I didn't do anything incorrectly. Okay, so I put in, so let's go to stat, tests. I want to do a t-test. Okay, mu naught is 14, x bar is 13. My sx, I put in 35, but sx should be not 35. See, that's what happens when you're not very clear with your notation, right? So it should be 3.5. 3.5. That's messing me up because that's too high, right? If you say what's the probability of getting something is a 49%, like that's a very high p-value. So now let's try to redo it now. Calculate. Okay, so I still have the, what is my test statistic is negative 0.9035. That's still the same. My p is 0.194899. Okay, and then x bar is 13, sx is 3.5, and it's equal to 10. Okay, all right, so this is more reasonable. So this is a probability of like 19.5%. Okay, so let's see here. So let me erase this, and we get 19.4899. Okay, more than, so probability of obtaining a sample as extreme or more extreme than 13 minutes is, what is that probability? It is p equals 0.194899, which is about 19.5%. Okay, now use the following sketch to graphically show the relationship between the standardized test statistic and the p-value. So my standardized test statistic is negative 0.09. negative 0.09, and the p-value is 0.19. It still looks a little odd. So at 0.19, which would say that this area, because it doesn't look like this area, maybe my sketch is off, that this area is equal to 0.194899. Oh, because my t is not 0.09, my t is negative 0.9035. Oh, I am so sorry. I keep making errors here. But notice how I'm able to catch the errors because I'm looking at my picture, because I'm saying to myself, hey, that doesn't look like an area of 20%. And the reason why is because my test statistic isn't supposed to be close to 0. It's supposed to be almost like it's negative 0.9. So this is going to be close to 1. Okay, so that's why it's so important to not just be, kind of plugging and chugging stuff in, but kind of you can check yourself because you know that P corresponds to a probability, So let's see here. So we need this to be closer to negative 0.9, which is over here. And now, totally reasonable that this is 20%. Okay. All right. And now this is a T, so we can shade the tail and the corresponding value. So we're doing a left-tailed. Remember, we're doing a left-tailed. Also, another thing is when you are, some people can get this. I've never been able to get mine to work. But when you are doing your, to interpret the, oh no, I need to switch. So at the 10% level of significance, there is not enough evidence to support the DMV's claim that wait times are, on average, less than 14 minutes. Okay. So, as you can see, the more familiar you are with the form and filling these out, the more practice you get, the more routine it will become, and the more skilled you'll become at performing a hypothesis test. Okay? So in conclusion, what have we done? We practiced finding critical values in a t-distribution using inverse t. And then we use the t-test to test a mean when sigma is not known. So we used the calculator, which is t-test. We did it with the critical values method, critical values and rejection region. Right, and then we did it using the chart that will be on the exam, chart for written homeworks and exams. All right, thank you very much.